Welcome back to the 26th part of Debugging at Scale, where we actually explain what the hell does map diagnostic context mean. We'll dive right back into the discussion in the previous part where we talked about best practices, starting with a big one. Some developers only read the log when they have a failure. They search and leave. Don't do that. Try reading it like a book. It should tell a story. If it doesn't, you need to fix the log so that the flow is obvious when filtering for a single user. SREs will need to go over these things, and if the log is inconsistent or weird, they can miss an important detail. Furthermore, you might notice errors that are marked incorrectly or for which you didn't give a notification. That's very important. Make a schedule for log reading once a week as part of your tasks. You notice something weird, file an issue with the relevant log lines. You might be able to fix the problem before it manifests at scale. I sometimes see log messages marked as warnings that should be info level, and vice versa. This is because every one of us has their own sensibilities of what level should something map to. This is problematic. The Logging Best Practices Guide should clearly map the levels and give concrete examples of edge cases from your codebase, specific log lines, and why each decision was made. Something like, we decided to make this log an info level because there's no situation where down the road this can lead to a failure. But if the behavior was changed to something like, we have here, then it should have been a warning. This is something we can enforce uniformly in code review. When we have clearly defined goalposts, the reviewer has something concrete to comment on. I can say I did that, and it's bad. Logs are fragile and change. An integration test that uses a log line to see if something is working will fail, and hard codes are bad behavior. Avoiding a double log seems obvious, but it isn't always. Case in point, this sample. We log an error on catch. Seems right and intuitive, but the generic error handling code should probably do the logging. In that case, the error will be logged twice, with no actual benefit. I spent ages reviewing duplicate stack traces just to make sure they're technically the same error. That's time I'm never getting back. If you were impacted by the log4j issue, this should be obvious. Any user submitted data should be sanitized before logging. This invariably means we will also have some unlogged information, but this is probably better than the alternative. Linters like SonarQube automatically detect problematic logging like that. Personally identifiable information is a huge issue. You can inadvertently log a credit card number when printing an object and accidentally violate regulations. PII Reduction lets you define masks that would remove such accidental logging. I discussed this before, and this is crucially important. Map diagnostic context lets us assign context to logging operations. This is a bit harder with asynchronous APIs, but is available there too. So if you have a log, you can also add the web request that triggered it to the MDC. Then when you look at the log in a viewer tool, you can see the context of the request. Every line will show you the context, such as web request that triggered it, the logged in user that submitted the request, etc. This way, we can filter logs to a specific user or specific request. This lets us focus on the context so we can follow a specific session. We can add information to MDC using code like this in Java. But there is a catch. We add such information to the MDC, we must remove it as well. If we don't, the information can pollute future operations. For instance, the user ID can become associated with an unauthenticated user. This can happen since threads in Java are pooled and other platforms reuse threads. The solution is to remove the MDC value when we're done with it. This is problematic because we might have a failure before the remove call is made. An exception might be thrown in the thread, and as a result, the MDC code might be missed. We need to guard against that and make sure that threads are clean. The strategies for that are too varied to include here, but there are usually best practices covered in the MDC documentation from your logging vendor. In Java, it's recommended to handle that cleanup in the thread pool code. With virtual threads, this will be even simpler since we won't need to clean up. When running in production, I typically set the log level to warning. I want to reduce ingestion costs, and I use log injection if there's something I need to know. I think keeping this log level forces us to really think about what we need in production and helps reduce costs. We might vary it for newly added modules to get them stable. One of the things we often do is run tests with debug logging while deploying production with a different level. That's a mistake. It might create a situation where the higher volume of logs impacts the result, for instance, race conditions, etc. It also creates a situation where important logs are left out. I hope these videos will help you improve your logging game and make your code easier to debug, both in production and locally. In the next video, we'll enter the huge world of testing. Brace yourselves. If you have any questions, please use the Slack channel to ask them. Thank you.